Today I am going to show you how to find a relationship between this modulus constant, modulus of elasticity. We are familiar with modulus of modulus of elasticity. There are four types of modulus of elasticity. Just I am telling you, first of all, I am telling you as a summary about four types of modulus of elasticity. First was Young's modulus, which is represented by Y, and second bulk modulus, which is related to volume and it is represented by K. You know. And third, which is shear modulus, and name of other name of this is rigidity of modulus, which is represented by eta, or you can say a small m symbol. So this was related to tangent, or you can say tangential. We can call it as a tangential modulus of elasticity. And last four, which was Poisson's ratio, and it is a different but little bit. And Poisson ratio is represented by this symbol. This symbol is used to show Poisson's ratio. Okay. You will be able to understand what is Young's modulus, what second bulk modulus, and third is shear modulus, rigidity of a modulus. But when it comes to Poisson ratio, it seems so difficult, but it is not actually. Literally, to understand the Poisson ratio is not difficult. Okay, it is a defined. If I define it, then from my language, not my language, but book also defines it like that, by saying it is defined as the ratio of lateral strain, yeah, to the longitudinal strain, where we know longitudinal strain is equal to alpha. We just consider longitudinal strain as a alpha, and this lateral strain, which is represented by beta. So beta upon alpha is equal to what? Minus will come if diameter is decreasing, then minus will come, minus beta upon alpha. This is a ratio of Poisson ratio. Here it was compulsory to understand this alpha and beta, because sometimes if you don't have any idea about this alpha beta, then you, of course, normally you will get confused. That's why I thought, my mind said that okay, I should explain about alpha beta. Okay, now you have got it. These are four modulus of elasticity, and among this four modulus of elasticity, we are going to find out relation between them, or you can say relation between among them. It's not difficult. Again, I would like to repeat. Look, first relation where we will find what is said in first relation, where three times bulk modulus. For this bulk modulus, we find out what change in volume. Here is where you have to do long process logically to find out a change in volume. First of all, we consider a volume whose each length of a cube is 1 meter, and hence what volume of that cube becomes 1 meter cube. So this is what volume of first cube was a length. Each length is one meter. So okay, we have found okay, this is going to length 1 meter length of the first cube, and was volume came out as 1 meter cube. But here we know bulk modulus is equal to change in volume. No. Bulk modulus is that how much stress, volumetric stress have you applied. Okay, how much? This is important. And when you applied volumetric stress, then how much volumetric strain you got how much? It is possible to get a volumetric strain when volumetric stress will be applied. Yeah, without stress it is not possible to get volumetric stress. So that's why it becomes important that we should have what volumetric stress. Okay, okay, now once we have once you got what one cube whose length is what 1 meter, 1 meter. Now we are going to apply volumetric stress. First case we saw what, not case but first part, just we got that this is a initial cube whose length, each length is 1 meter and the volume is 1 meter cube. You can consider this part as our first part. Now in the second part we are going to apply what volumetric stress. When you will apply volumetric stress, either it can be more or less, either it can be tensile or compressive, it depends on you. If this is an tensile, so of course tensile, it means where surface where you applied what deforming force, deforming force, that surface will increase in length. Am I right? By nature it will happen, I know. So that surface will increase when you will apply deforming force, and this is what is a volumetric stress that you applied. Now when you applied this stress, how much that from the initial position that cube did come till the final, this is what a change in volume, this is what a change in volume. And now we are going to see, or you can say we are going to find out what is the length of the new cube. I'm saying new cube. Initially we had, let's just suppose old cube. Now we got new cube when we applied volumetric stress. Okay, when we applied, of course we will get a new cube. Now it's our duty to find out what is going to be our length of new cube, new cube. And if you find let's suppose you found one length, length of one side of a cube, don't you think that each side of cube would be equal? Of course it is a fact. Yeah, if you found one length of this side of the cube, it's done. You have got also measure of left two sides. Okay, okay, now you have got what length, measure of length of the new cube. Got it. Now it's a time to find out what volume, volume. Am I right? I'm not saying volume of a old cube, no, I am saying volume of a new cube. New cube, you just got the length of the each length of the new cube, but not volume. So for volume you have to multiply each means 3. You now to calculate volume of any cube, just we multiply length multiple breadth multiple h height, and that is how we get a volume of any cube. Same you have to do with this new cube. Before this you got what length, just multiply LPH and you will get volume of new cube. Now after this, this is done. After this you have to find out the change in volume. Change, how much change did you get, how much. So logically and naturally, or you can say practically think. Initially this was like this. Okay, just you applied in this side, you applied what volumetric stress. So finally it came over here, it came over here. Will it happen? Will it happen? Answer is yes, it will happen. Now let's suppose this is O. Hold on, marker is not working. This is a O and this is A and this is a dash, A dash. Okay, OA length of this was 1, as I said, So initially, this is 1 cube, and from here to till here, try to understand. In this figure, you have a 2 cubes. First, this is OA, and second, we have this from A to A dash. Am I right? 2 cubes you are getting. For this, you know what is the length, what is the h length, and you also know volume this cube. But when it comes to this, as you saw, we found what h length. But remember, cubes looks like this, not a cuboid, where each side is equal. So okay, from A to A dash. Now here we have to find out a change in volume. Change in volume. Yeah, change in volume. Change in volume. How to find? To calculate this thing, just we have to do is that just subtract this bigger volume. Just to subtract this smaller volume from this bigger volume. Means O dash O A dash minus O A. From here you will get change in volume. Change in volume. That is how you will get change in volume. Once you get change in volume, so finally now you can write Burko modulus, which is represented by K. This is known as F upon A, and change in volume, no. V will go upward and change in volume will come downward. So this is a formula to calculate a Burko modulus. It tells you, Burko modulus tells you that how much a object can be compressed. Let's suppose we say in the chapter of fluid mechanical properties of a fluid, we say that you should have an ideal fluid, means incompressible fluid, where fluid cannot be compressed. But by nature, little bit, very less we can compress, very less. Amount of that force is very less. Okay. So here we are saying that yeah, body can fluid, if it comes to fluid can be compressed, but along to what is it? Volumetric stress will be very less. If we see by nature, this is going to be very less. Okay. Now, what was the requirement? This volumetric stress and this original volume, which is this 1 meter, 1 meter cube. This is original volume, and change in volume we will find out from this process, change in volume. We found this by reason. What is the reason? There was a need to calculate this change in volume. Answer is yes, because in calculus, what calculus? In bulk modulus, we should have this original volume and change in volume. So this change in volume will come how? When we will apply a longitudinal stress, not longitudinal but volumetric stress. Volumetric stress, then one surface will come, or you can say will increase. That is how the new cube will come out, and then we will just subtract this old volume from new volume. Then you will get change in volume, how much it changed its volume, it increased its volume. Yeah. So for now, as of now, I'm not going to tell you just little bit information. My mind was saying that I should tell you about, I should give information about this bulk modulus, where you will feel that this process is very low. That's why it should become. So I decided to explain it. Finally, we can see there is a one relation, okay, a relation among modulus of elasticity, where one process to calculate this change in volume, you will see very less, very more. This is a uh, very big. So for that relation, I just explained this. I just explained this. Okay. Now only that relation you will get that the process is varying, but apart except that relation, for example, three more. Except that relation, we have three more relation among modulus of elasticity. Uh, you will not feel for those relations of modulus of elasticity. You will see that okay, in this part process is not long. It is a very means you will apply very less efforts. You will be able to apply very less efforts. So I am ignoring. I am not taking the first relations among the modulus of elasticity. Apart, except this, I took this is second. You can say relation between what Poisson ratios and bulk modulus and rigidity of modulus. Rigidity of modulus, three times of bulk modulus. First relation, which is between just be alpha, not alpha, Young's modulus. I think first relation is Young's modulus and bulk modulus. One last. Uh, one last is eta. One last is eta, not Poisson ratio. Yeah, Poisson ratio will come, but not eta and Poisson ratio. This is our first relation. Young's modulus, bulk modulus, and Poisson ratio. Why will Poisson ratio will come? It will tell you. It will tell you that if when you are going to increase one side length or length, let's suppose you are increasing a length, okay, you are applying longitudinal stage. What will you observe? You will observe that upward and the downward part of the body is decreasing. Is decreasing by nature. It is a possible. So that is where Poisson ratio comes into picture. Okay. As of now, let me explain this relation between Poisson ratio, bulk modulus, and rigidity of a modulus. Okay. Hold on. Have a look for a few seconds. Look, you have to take first two relations. For example, we know we know that Young's modulus is equal to 3 times of bulk modulus 1 minus 2 Poisson ratio. This was our first relation. Am I correct? Just before this, I explained about this. Little bit information, not complete. Here is where you will realize bulk modulus. So you know that our first relation is this relation between Young's modulus, bulk modulus, and Poisson ratio. Okay, it is written like that: y is equal to 3 times of k into 1 minus 2 Poisson ratio, 2 times of Poisson ratio. Okay, and the second relation, which is and second relation, which is 2 times of eta and 1 plus Poisson ratio. This is our second second equation, you can say. So this is 2 relations are compulsory. You have to keep remember not two but three. From if you know these are two relations, I'm not saying find out a relation between this relation between this. No, I'm just saying that you know this are about these two relations. If you know, it will become very easy to find out relation between them. Now this is one equation and second equation is in front of you. Now from equation number 1 and 2, from equation number 1 and 2, equation number 1 and 2, I am saying from subtraction. No, you see over here, just see in this one side and in this equation one side, both are equal, both are same, Young's modulus and Young's modulus, so both will cut to each other. Okay, so this one side you have to take 3k 1 minus 2 quotient ratio, and from this second equation 2 eta 1 plus quotient ratio, 1 plus quotient ratio. Now your work is to simplify. Your work is to simplify. How to simplify this? How to simplify? Look, you have to come over here 3k minus 2 eta upon 2 n eta plus 3k. Till here you have to come anyhow, logically, with the rules of mathematics. With the rules of mathematics. How would you like to come? This is in your hands. Okay, this is in your hands. Now just multiply. Look at how 3k into 1, 3k, 3 to just 6, 6k, quotient ratio is equal to 2n, and now you can multiply this 2 quotient ratio with this terms. It will become 2 eta 1 2 eta plus 2 eta into quotient ratio, you would say 2 eta quotient ratio. Am I right? Now we want this one side. Am I right? So just to shift this in this side 3k, and this will become 2 eta 2 eta quotient ratio plus 6k quotient ratio. Got it? No problem. Now you can see, brother. Now you can see this one side and this one side. Till here we have come. Till here. We need only this denominator. How to bring? See over here. We don't need to modify this because we want it. There is no need to modify it. It should be as it. Okay, as it 3k minus 2 eta. So in this side you can say yeah, if this is LHS, so this should be RHS. So over here 2 will come out as a 2 2s are 1 and 2 3s are 6, but you see, carefully see, in these two terms here 2 will come out, and this quotient ratio is common, so I think quotient ratio should come as well. Yeah, now n will be over here plus 2 3s are 6 and k will be as it, this bracket and this bracket. Till here this is correct, no problem. We want what? 2 into and this bracket, so 2 into this bracket, if you will shift just over here in denominator, Are we shifting with the rules of mathematics? Answer is yes. It is making sense. So 3k minus 2a, and just to shift this, uh, you can say, you you can't, you would say, should I not shift this only bracket? Why why are we going to shift this 2 as well? Answer is we need over here, brother. We need 2. Okay, we need, according to requirement, you have to move on. Okay, so this, just shift this in denominator, 2n plus 3k, and this portion ratio will be as it. Finally, you have brought this thing, equation. That is all you have to bring. Got it? Was it difficult? No, not at all. Just main thing in this relation was this two equation. Y is equal to 3 times into 1 minus 2 portion ratio. Just understand that from this 3 times of bulk modulus. Just to understand from this that one length is increasing and two sides of the cube is decreasing. Just portion ratio, from portion ratio, just understand two sides are decreasing and one side is increasing. It happens. Yeah. Now second equation is what? It is telling you one length is increasing, one side is increasing. This portion ratio I will not explain about this right now. First was a compulsory. In a separate lecture I will discuss about this, special for this second relation. So finally you saw how to bring this equation with the rules of mathematics. Again, I would like to repeat it as a summary. This was our equation. Equation was found out a relation between a portion ratio and a bulk modulus and a shear modulus. It is also known as the rigidity of a modulus. We will start by saying that we know that we have two equations, or you can see two equations, not a relation, two equations. Y is equal to 3 times of 3 times of 1 minus 2 portion ratio. First is easy to keep remember for the long term. Just 3 times of bulk modulus. 1 is increasing, one side is increasing and two side is decreasing. 1 minus 2 portion ratio. This is your first equation. And second you have to write this. Don't shift it this that side. Okay, y is equal to 2 times of eta into 1 plus portion ratio. 1 plus portion ratio. Okay, and this is your second equation. Just from one equation, from equation 1 and 2, you can see in one in both equations, in one side both are equal. Y is equal, both will cut to each other, and this will be equal to this. And just we have to simplify. Just remember, we have to come till here. Anyhow, you have to come till here. Here in the process, anything was not difficult. You see, just we multiply this with this and this with this. That's it. We used to do like that from childhood, I think. So just multiply this by this two terms and then see here 2 is a common, 2 is a common, and just to shift this over here, because we need only one portion ratio in one side, that's why I shift this portion ratio in this side. Okay, and that is how come over here. That is how you have to come till this equation. So yeah, you have to keep remember this also equation, so that you know, yeah, I have to come till here. Otherwise, the process will go where you don't know. Yeah. Even further it can be simplified, but we don't need, na? We don't need. Why should we simplify it further? Yeah, why? Just have a look. Just have a look. Now second equation, not equation but relation between modulus of elasticity I am going to show. So next, next is Young's modulus and bulk modulus, and it in the previous हमने पिछले पार्ट में देखा relations between Young's modulus, bulk modulus and portion या portion ratio, जहाँ पर हमने लास्ट इक्वेशन में पोर्शन को रेशियो को एक साइड रखा था और ये इक्वल था किसी इक्वेशन से, किसी वेरिएबल से, किसी टर्म से है। लेकिन पिछले पार्ट में हमने क्या देखा, रिलेशन बिटवीन यंग्स मॉडुलस, बल्क मॉडुलस एंड पोर्शन रेशियो। अब इस पार्ट में सिर्फ हमने रिप्लेस कर दिया है पोर्शन रेशियो को रिजिडिटी ऑफ मॉडुलस से, और कुछ नहीं। अब हमें रिलेशन फाइंड आउट करना है इसके बीच में, इसके बीच में। हाँ वही, नॉट वही बट थोड़ा बहुत थोड़ा सा ट्विस्ट है इसमें, थोड़ा सा ट्विस्ट है, उतना सिंपल नहीं है जितना कि हमने पिछला पार्ट में देखा। तो लेट्स स्टार्ट बाय सेइंग दैट वी हैव व्हाट y is equal to 3k 1 minus 2 portion ratio. Now this is the first relation among modulus of elasticity. Till here you know, but I said there is a twist. You have to wait that twist, for that twist, okay? Till here you know, this is our first relation, and just little bit simplify it, not too much, little bit. Just bring this 3k in denominator, just y upon 3k is equal to 1 minus 2 portion ratio. First of all, I will now let me write where should we stop. Yeah, this is important. Where should we stop? This is important. Otherwise, it will going on. It will going on. So I would say it should stop over here. 9 upon y is equal to 1 upon k plus 3 upon eta. Here is where we have to stop. Okay, here is where we have to stop. Now write a second relation. As I said, two relations is a compulsory, we have to keep remember for the long term. So this is one equation, this is your one equation, and we just simplified little bit, just we simplified and it came out as ये ऐसा है जिसको हम इक्वेशन नंबर 1 कह रहे हैं। अब इक्वेशन नंबर दूसरा लिखना है, इसके बाद जो इक्वेशन नंबर दूसरा आता है, याद रहे ये हमारा फर्स्ट इक्वेशन है ताकि हमारा दिमाग कंफ्यूज ना हो सके। सेकेंड इक्वेशन जो कि है y इज इक्वल टू 2 टाइम्स ऑफ एटा 1 प्लस पोर्शन रेशियो, ठीक है। अब ये सेकेंड है, लेकिन इसमें थोड़ा सा मॉडिफाई नहीं, लेकिन थोड़ा सा इसको सिंप्लीफाई करना है। इससे 2 एटा को डाउनवर्ड लाना है, जस्ट 2 एटा को डाउनवर्ड, 1 प्लस पोर्शन रेशियो। अब देखा जाए तो एक साइड में सिर्फ पोर्शन रेशियो बच गया है, एक साइड में सिर्फ इक्वेशन नंबर 1 एंड 2 में देखा जाए तो एक साइड में सिर्फ पोर्शन रेशियो बच गया। शायद यही रीज़न होगा कि हमने ये दो टर्म्स को 3 टाइम्स के और 2 टाइम्स n को इस लेफ्ट साइड में शिफ्ट किया है, शायद यही रीज़न रहा होगा। तो अब क्या करना है कि जैसा कि हमने पिछले पार्ट में कहा था कि दो इक्वेशन लिया, फिर इक्वेशन नंबर 1 और 2 चले थे हम लोग कुछ इस तरह से। इसमें क्या करना है कि दोनों इक्वेशन को लेना है लेकिन ऐड करना है, एडिंग इक्वेशन नंबर 1 एंड 2, एडिंग इक्वेशन नंबर 1 and 2, okay, 1 and 2, got it, no problem, no problem. Till here I think you will not have any doubts. अब adding equation number 1, just add this y upon k 3k plus y upon 2k, like that. And yeah, let me write y upon 3k plus y upon 2a. Am I right? 1 minus 2 quotient ratio, got it, no problem. Then we have 1 plus quotient ratio. Okay, this 2 minus 1 it will become 2, and minus 2, so only 1 quotient ratio. So finally we have y upon 3k plus y upon 2 eta, and this is equal to 1. Am I right? Not 1 but 1 plus quotient ratio, not plus but minus, not plus but minus, 1 minus quotient ratio. Check it, am I correct or not? Check it, y upon then y upon, so it should be 3, it should be 3, 1 plus 2 and 2 plus 1, 3. Hold on, here this 2 will be over here, and then this 2 ones are 2 plus 2 quotient ratio, and this will be 2 only. Now look, 1 plus 2 and this 2 quotient ratio will cut to each other. So finally we have y upon 3k plus y upon 8r is equal to 2 plus 1 will become 3, will become 3. Now simplify this fractions, I would say fraction, 3k eta and then 3k, so y eta plus n, so y 3k eta, and 3 will be as it, 3 should be as it. Now when you will see when you will shift this over here with this, so this will become 3 3 is 9, 9k eta, 9k eta. So and here Young's modulus is common, Young's modulus is common, just do like that. Let me write, so this y is common, n plus 3k, n plus 3k, and this will become, and this side this will become 9k eta. Are we correct? 9k eta. Now this 9 9 तो आ गया, और यंग्स मॉडुलस को अगर इस यंग्स मॉडुलस को अगर यहाँ शिफ्ट करें तो 9 अपॉन वाई आ जाएगा, 9 अपॉन वाई आ जाएगा, जो कि हमारे इक्वेशन में है, जो कि हमारे इक्वेशन में है 9 अपॉन के। तो अगर हम n प्लस 3 के लिखिए और 9 अपॉन वाई के बेटा, ये तो कंप्लीट है, ये तो कंप्लीट है। लेकिन what about this, what about this, if we shift this k in over here, it will come in divider. Let's do n plus 3k upon kn is equal to 9 upon y. N upon k plus 3k upon n is equal to 9 upon y. Here see 1 upon k, okay, and 3 upon n. We have to remove this n and k. How to remove? Logically, with the rules of mathematics. With the rules of mathematics, I would like to remove. I would like to remove. Look, just shift this 9 over here, 9 in this. So I think it should become 9k plus 3k upon 9 n 1 upon y. 3 3 is a 9. 3 3 is a 9. 3 3 is a 9. 9 kn. So kn came downward. Kn came downward. So this should become kn, and it also came. So k will cut to each other, and n will cut to each other. So finally we have what? 1 upon k plus 3 upon n plus 9 upon y. So 3 upon n and 1. Yeah, finally हमने इस इक्वेशन को लाया कुछ इस तरीके से. देखो के एन तो यहाँ चला गया, फिर अगर इसको तोड़े तो क्या होगा? एन अपॉन के एन हो जाएगा, फिर 3 के अपॉन के एन हो जाएगा. अब क्या होगा यहाँ पर? एन से एन कटेगा, फिर यहाँ के से के कटेगा, फिर बच जाएगा 3 अपॉन एन इट इज इक्वल टू 9 अपॉन वाई. बस साफ सूत्र लिखना है, 1 अपॉन के प्लस 3 अपॉन एन इट इज इक्वल टू 9 अपॉन वाई, जो कि इसके बराबर है. यही था हमें फाइंड आउट करना था, यहीं तक तो हमें आना था. ठीक है, कुछ इस तरीके से सिंप्लीफाई करके आना है. इस तरीके से सिंप्लीफाई करके आना है. अब इसके बाद इसके बाद दो रिलेशंस और हैं. ये दो रिलेशन, तीन रिलेशंस और हैं. एक पोर्शन रेशियो है, उसका डिफरेंट